recording.
Thank you, Jordan.
All right. My name is Jordan. I'm an environmental biology major here at Western. And today I'm going to be giving my presentation on Dutch elm disease. Start off with a little bit of background for Dutch elm disease. Dutch elm disease is a potentially lethal disease that is caused by the Ophiostoma novi only and Ophiostoma only fungi. Dutch elm disease is primarily spread through bark beetles as vectors, spreading spores of infected trees to healthy trees. This is usually done throughout the life cycle, where the larvae are laid in infected or dead, rotting wood. And then when they grow older, they feed on live trees rather than dead trees, and they bring those spores along with them, infecting previously uninfected healthy trees. The history of Dutch elm disease. It was first introduced to the United States in the early 1930s. And as you can see on the map on the right side, Dutch elm disease is now widespread across most of the US, especially the eastern US and the Great Plains and Midwest regions. The impact of Dutch elm disease. It's caused by the movement of the Ophiostoma noviomi and Ophiostoma ulmi fungi up the vascular system of the tree, along with the flow of water, which results in the wilting of leaves. The most susceptible elms are the American elm, red elm, and rock elm, and the Asian and European elms have shown to be more resistant because they have lived with this fungi and disease a lot longer and have been able to develop more resistance. How to identify Dutch elm disease? The two primary things to look out for are the wilting and yellowing leaves, as you can see in the top right image. And then the bark beetles will leave visible galleries that you can often see in the wood of the tree, indicating that bark beetles have been there, potentially spreading disease. How can we combat Dutch elm disease? There are multiple ways to do so. One of them includes removing breeding sites from bark beetles, like cleaning up dead or infected wood, which takes a lot of physical labor. You can remove infected branches of the disease before it spreads to the main stem of the tree, which again poses some issues due to the fact that it requires a lot of monitoring and physical labor.
Pen and paper, one man may put. But what come on in person? Busy.
You can also treat it through
Busy. Hey.
fungicide injections in order to prevent the fungus from infecting it. And then lastly,
Experience you. Check.
Lastly, what is going to be is the Dutch elm disease cultivars for new plantings, which is going to be the main focus of this presentation. Research done through the University of Minnesota on Dutch elm disease resistant elms. They developed a project and researched in an attempt to create elms that are more capable of resisting disease. The research focuses on answering three primary questions, which are: which elms are disease resistant? How can we best propagate resistant elms? And how can we reintroduce these elms into local communities? To answer what elms are disease resistant, they went out and they surveyed sick or dying trees of multiple different types of elms, and they took cross sections to identify whether this dying of the tree was due to Dutch elm disease or not. The first subject was the American elm, which is seen in the top left. And then upon taking the cross section and looking at it, they found that there was vascular staining within the tree, indicating that it had been infected with Dutch elm disease, as well as the presence of Ophiostoma novi only. The second subject was the Triumph hybrid elm, which is an elm it's a hybrid elm developed by the Morton Arboretum. And the Triumph hybrid elm subject that was experienced dieback and wilting leaves. In the cross section, there was no presence of Ophiostoma fungi, indicating that the cause of death was not, or the cause of the disease was not Dutch elm disease. And further studies would have to be conducted to determine what that causal agent was. The last and final subject that they looked at was the Accolade hybrid elm, another hybrid elm developed by the Morton Arboretum. It experienced 25% dieback as well as a wilting crown. And then when they went to study it, the Ophiostoma ulmi and novi ulmi were both absent, indicating that it as well was not dying due to Dutch elm disease. How can resistant elms be propagated? Resistant elms can be propagated in a number of ways, but the primary way that we see it is through grafting, and grafting involves taking a cutting or some sort of piece from the upper area of the tree and combining it with a piece of the rootstock to form a piece that can be cultivated and grown. There's a cutting. You can use a cutting technique, which involves cutting a vegetative part of the plant that can just be stuck in the soil and potentially grow roots and then grow into a tree from there. There's layering, which is similar in the fact, but you're not cutting it, you're sticking a piece of the tree, a vegetative part of the tree that can potentially grow roots, and you're leaving it connected to the parent tree and then growing a new tree from there. And then there's breeding, which is usually done through cross-pollination in order to get the desired traits of resistant trees. The reintroduction of resistant elms. For this experiment, they took 23 different survivor trees, which include those hybrid trees that are disease resistant. And they created 300 grafts to be used for inoculation studies. An additional 200 grafts were made for the purpose of reintroduction into parks and preserves across the state of Minnesota. The importance and application, being able to study which trees are more resistant to disease and being able to propagate them is a large step forward into combating the rapid spread of Dutch elm disease. And then being able to actually reintroduce these resistant grafts that can grow into more resistant trees will help improve the long-term resistance of elm communities, limiting the rate of spread. And that concludes my presentation, and I'm open to answer any questions.
All right, thank you, Gordon. So please ask some questions as part of your participation in class today.
Yeah, Michael?
Hi, I do have a question. The only grafting I'm familiar with used very small twigs or branches, if you will. Is that what they were grafting onto the existing trees in the field, or was it something bigger than that?
They were using twigs and branches for this grafting experiment. From what I researched, you can also use grafting through budding, taking the buds of trees as well. But for this experiment, they were using twigs and sticks. Any other questions? Yeah, Michael again.
I'll ask you another one. So they would take smaller twigs, if you will, from a disease-resistant tree and grafting them onto a tree in the field that did not possess such resistance, correct?
Yes.
So,
Yeah.
so just that twig confers the resistance. Nothing from the parental tree, if you will.
Not that I am aware of. I believe, yeah, they were taking the twigs of resistant trees and putting them on trees that are already there within the community. And then I think that more studies are kind of being done
Yeah.
with that, so they don't really have the results of whether or not that resistance is enough yet. But
Mhm.
yeah, that'll
Well,
be
it's odd that that implies there's nothing related to xylem or phloem. You know, it's all literal structure, tissue. And that shocks me a little bit, surprises me in a good way, as long as it works, so.
yeah. I mean, I don't know the results of that yet, so it'll be interesting to see if that's something that
Mhm.
will
Agree,
work.
that will be interesting, thank you.
All right, who else has a question? Samia, are you presenting today?
No, sir, I'm just having flu this week, so
What's that? Samia, did you say you're ready to present?
no, sir, I'm having a flu, so
Are you gonna be able to present next week?
yes, sir.
All right, so who else is on here that hasn't presented? Oh, go ahead and, Jordan, go ahead and pause it or stop the recording. And then if you want, you can make me host again.